Question 7, solve the following equation for the x. Example A, 27 to the power x equal 9. So solve for the x. So first of all, we change the 27 is 3 cubed. 3 times 3 times 3 is 27. Then to the power x equal 9. Change this to the same base, 3. 9 is 3 square. And then use the power rule. 3 times x equals to 3 square. Now they have the same base, 3, so the exponent should be equal. So we got is 3x equal 2. Then divided by 3, both sides get x equals 2/3. And change to the same base, you can solve it. Like another example, this one example, it's a to the power x equal 1024. A to the power x equal 1024. So 8 is 2 cubed. 2 times 2 times 2 is 8. To the power x equals 1024 is 2 to the power 10. You change to the same base. Then use power rule is 3 times x. So you got 2 to the power 3x equals 2 to the power 10. And then now you have the same base. So exponent should be equal. So 3x equal to 10. Then divided by 3. So x equals 10/3. So you change to the same base. You can get can solve for the x. Next one will be this another example. Example 25 to the power x equals 625. So 25 is a 5 square. To the power x equals 625. It's a 5 to the power 4. 625. You can do 625 divided by 5 is 125. Divided by 5 is 25. Divided by 5 is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's 5 to the power 4. And use the power rule. 2 times x. 5 to the power 2x equals 5 to the power 4. Then 25, same base is 5. So exponent should be equal. 2x equal 4. And then divided by 2. And so you got x equal 2. Another example. This example, 1000 to the power x equals 100 to the power x equal, and what is the x will be. So 1000 is 10 cubed, 30 cubed. To the power x, 100 is 10 square, 20, so square to the power x. And use power rule. You change to the same base is 10. So power rule 3 times x. And this is 10 to the power 2 times x. They have the same base is 10. So exponent should be equal. So you guys 3x equals 2x. Then you subtract 2x both sides. So you get 3x minus 2x equals 0. So 3x minus 2x is x. So we get x equals 0. 1000 to the power 0 is 1. 100 to the power 0 is 1. So x equals 0. The next question, B, question 7b. Figure out solve for the x. Example, log, here base is x, 1/8 equals -3. And what is x will be? So first of all, we got to change to from logarithm form to exponential form. How to change? Formula is base is b and y equal x is equivalent to b to the power x equal y, y equal b to the power x. And that is the definition of logarithm. You can change from exponential form to logarithm form to exponential form. So this given logarithm form change to exponential form, b to the power x equal y. So x to the power negative 3 equal 1/8. So we get x to the power negative 3 equal 1/8. Now x to the then use negative exponent rule. Negative exponent rule is x to the power negative n equal 1 over x to the power n. So bring down to the denominator, and negative 3 change to positive 3. Change the sign, equals 1 over 8. 8 is 2 cubed. Now the 2 are the 2. So the numerator is 1. So denominator should be same, equal. Then they will equal. So you got x to the power 3 equal 2 to the power 3. Now the 2, the exponent are equal. So the base should be equal. So you got x equal 2. And you can check it. 2 to the power negative 3. 2 to the power negative 3 is 1 over 2 cubed. That is 1 over 8 equal. So x equal 2. Another one, another example. This example, it's log x 19 equal negative 2. How to solve it? So first of all, change b to the power x equal y. So x to the power negative 2 equal 19. So we get x to the power negative 2 equal 19. Then x to the power negative 2 equals 1 over 9 is 3 squared. And then you can change to 3 squared, switch up to numerator 2. Exponent change to negative 2. I'll use this negative exponent rule. This n, if you go to numerator, you become negative, change the sign, become negative. And since the 2 have same exponent, so the base should be equal. So it's x equals 3. Next example. This is still question 7, B. Example. It's log x 625 equal 4. So first of all, also change to exponential form. X to the power 4 equals 625. Now 625 is equal 5 to the power 4. 625 equal 5 to the power 4. You do 625 divided by 5 is 125, divided by 525, divided by 5 is 5. 1, 2, 3, 4. 5 to the power 4. And since the 2 have same exponent, so base should be equal. So x should be to the x equal 5. Next one, this example, another example. Log base is x 1 over 32 equal 5. So what is x will be? So also change from logarithm form to exponential form. We do base is x to the power 5 equal 1 over 32. 1 over 32. And then x to the power 5 equals 1 over 32. 32 divided by 2, 16. Divided by 2, 8. Divided by 2, 4. Divided by 2. 1, 2, 3, 4, 5 is 2 to the power 5. Then x to the power 5. So this is 1 to the power 5. It's 1. So equal 1 over 2 to the power 5. 1 to the power 5, it's 1. And 2 to the power 5. So this you can write down, go 5 out. So the same have the same exponent. So the base should be equal. So you got is x is 1/2. Next question. C. 7C. Example. The question say 7 to the power x equals 6 using common logarithm. They don't put down the base, means base is 10, or natural logarithm, ln. In the final answer, do not use calculator. So example, let's see this example. 8 to the power x equals 7. Solve for the x. Solve for the x. So how to we do we will question say use either natural logarithm or common logarithm. L, because calculator has the two key, the two button. You can press the two button. You can figure out. But here do not ask you to go further figure out, and just leave the answer with the natural logarithm or common logarithm. So this kind of equation problem, first of all, we will take either one. You can take common logarithm. I take natural logarithm, either one. Normally it's natural logarithm. I take this a to the power x equals 7, take ln on left, ln on right, they still equal. And then use power rule, this go from, power rule, x go from. So you get x ln 8 equal ln 7. And solve for x. Solve for x divided by ln 8, divided by ln 8. ln 8 cancel, and you get x equals ln 7 over ln 8. And this you can use calculator and press the key ln 7 and then press ln 8 divided. You will get in decimal. But here, let's say you don't need to, you leave answer with the natural logarithm or common logarithm. In the final answer, do not use calculator to further figure out in decimal. And another second example, it's this is still 7C example. E to the power x equal 7. Now, since solve for the x, since this base is e, so you use natural logarithm. So you do e to the power x equals 7. On the left, take ln. On the right, take ln. And they still equal. Then use power rule. This x go from. Get x ln e equal ln 7. So since ln base is e, so ln actually is log base e. Base le is ln. And then take e equal ln 7. So the formula is log if a base is bb equal 1, because b to the power 1 equal b. So for natural logarithm, Lee also equal 1, because e to the power 1 equal e. So this is 1. This is equal 1. So x times 1 is x, so you got x equal ln 7. Since this is 1, so you take ln, this is, you use natural logarithm. This you got 1. 7. Next question, example. This one. 10 to the power x equal 43. Example. 10 to the power x equal 43. Solve for the x. Since here base is 10, so use common logarithm. So then 10 to the power x equal 43, and use log, common logarithm. And use power rule, this x go from. So you got is x log 10. And this is a common logarithm. Base is 10. And log, do not write out the base. This means the base is 10. And since use same formula, log BB equal 1, log EE equal 1. So log, if 10, 10 also equal 1 because 10 to the power 1 equal 10. So this is 1. So this part equal 1. And then x times 1 is x. So equal log. Common logarithm 43. So you in calculator have this common logarithm button. You hit that button, 43, you can get in decimal. But here ask you to leave answer with using log, common logarithm or natural logarithm in the final answer. Do not use calculator. So you just leave an answer with common logarithm or natural logarithm. Then next example, this example is 100 equal e to the power x. E to the power x. So solve for the x. Since here is e, so you 100 equals e to the power x. So you use ln both sides. And this go from, you got x. So you got ln 100 is 10 squared. And the x go from ln e. And what is ln e? ln e is just log EE, which is equal 1. So this part equal 1. So x times 1 is x equals this 2 go from 2 ln 10. And you cannot go further. So it's 2 ln 10. And this ln 10 you can use calculator to figure out in decimal times by 2. That's answer in decimal. But here do not ask you to use calculator. Just leave an answer as ln or logarithm, natural logarithm or common logarithm. Question D. Solve for the x also. It's this is a 7D example. Example like this. ln 5x plus 3 equal to natural logarithm ln 7 ln x minus 17. Solve for the x. Since both are ln, so this part should be equal to this part. So we got 5x plus 3 equals x minus 17. Solve for the x. So the x move over, change the sign is minus x. 3 move over, change the sign, become minus 3. Combined, 5x minus 1x, 4x equals, this combines negative 20. Then divided by 4. 4 cancel, so get x equal negative 5. Now you have to go put back into the original to check. Always. Check with 5x plus 3. 5x plus 3 is 5 times x is a negative 5. Plug in. Check. Negative 5 plus 3. And you got negative 25 plus 3. And you got negative 22. And you got negative. If you put x minus 17, it's also negative 22. Negative 5 minus 17 is also negative 22. So this x equal negative 5. And this left side is ln negative 22. Ln this negative 5 plug in, you got ln 22. ln negative 22, undefined, no answer, no value. Why? I'll show you. Because ln is log base is e. If negative 22 equal what? And you change exponential form is e to the power what? Equal negative 22. E is a positive number. to the any number, like e to the power 0 is 1. Like e to the power positive 2 is going to be positive because e is about 2.7 something and square is still positive. But negative, like e to the power negative 2, and you put down become 1 over e to the power positive 2. It's still positive and never negative. So e to the power what equal negative? No. No such number. No answer. Undefined. E to the power what equal negative 22? No answer. So undefined. So when you so this for the logarithm function, this domain, this part cannot be negative, need to be positive, cannot be 0. Cannot be 0. So like you got -5, you will make this negative. So this is invalid, not the solution. So for this question, you will answer no solution. No solution. No solution. So for exponential function, like x original function map to b to the power x, b is a positive. B can be a positive number, like but less than 1, like 1/2, 1/2, and 1/3. And to the power x, domain for this function, this side is domain for f function, and put down the range. Domain is R for f function. Range is y has to be function value is positive. Because b is positive, to any power is going to be b to the power x for any real numbers plug in. Always positive. Like for example, b is 2. 2 squared is 4. It's a positive. If if x is a negative 2, and you got 1 over 2 squared is 1/4, it's still positive. If x is 0, 2 to the power 0 is 1, still positive. So no matter what kind x, real numbers, x is positive, b to the power positive is positive, and because base is positive. And then if b to the power 0 is 1, is still positive. If x is negative, b to the power negative, b is a positive number, and bring down to the denominator, become positive exponent, and become positive. So the range is positive. It's an inverse function. F inverse, we give a special name called log base b. Special notation, log base b. So, and this side is y. So you got log base b y equal x is equivalent to y equal b to the power x. Y equal b to the power x. So that's the first formula, right? So for logarithm function is a map. This side become domain, and this side become range. So domain, this side, what's the number you can use for logarithm function? This part, y should be greater than 0, positive number. You only can plug in L natural logarithm, this part, logarithm base is e. This part need to be positive number, then you can get the value. You can get the range value. So if negative, undefined, because there's no e to the power what number equal a negative number. No such number. It's e to the power any real number is going to be positive, never negative. So you never get a number x such that e to the power x equal negative 22. So for logarithm function, natural logarithm negative 22 equal what? Undefined. So this question you got negative 5, you plug it in, make this negative, this we call argument. Argument negative function negative is not the solution. This is invalid solution. So this is no solution. No solution. Next one, let's see another example. Next example is this example. ln 5x minus 2 equal ln negative x plus 10. Now it's the same way. You just because both are take the same function ln, so the argument should be equal. 5x minus 2 equal negative x plus 10. Then you solve for the x. So move this, add x both sides. So it become add x. And add 2 both sides become 10 add 2. Then 5x add 1 more x, 6x equal 12 divided by 6, x equal 2. And you always have to plug it into this argument of the function, check. Check it. You have to check. 5x minus 2 is 5 times 2. X is 2. Plug it in. Minus 2, which is 8. And use this one, negative x plus 10. Negative 2 plus 10, also 8. They are equal. They are positive. Then x equal 2 is the solution. X equal 2 is solution. And next one. Next example. This one. And the base is 2. X squared minus 33x equal 2. And solve for the x. So this one, first of all, you have to change from logarithm form to exponential form. Y equal b to the power x exponential form. Change to logarithm form is log by equal x. And change from logarithm form to exponential form is b to the power x equal y. So it's 2 squared equal this argument. So it's x squared minus 3x equal 2 squared. 2 squared equal this. Then this one is x squared minus 3x equals 2 squared is 4. Minus 4 both sides. And put it in standard form of the quadratic equation equals 0. Then factor it. X equals 0. You need to find two number. Product equal negative 4. Add together is a negative 3. So will be negative 4 plus 1. Tying together is a negative 4. Add together is a negative 3. Then either x minus 4 equals 0 or x plus 1 equals 0. Then solve for x. X equal 4 or x equal negative 1. Then you have to check. Let's check x equal 4. You have to plug it into here. Check with x squared minus 3x. 4 plug it in. 4 squared minus 3 times 4 is 16. Minus 12 equal 4 is positive. Positive. And check this with also check with x squared minus 3x. Negative 1 squared minus 3 times negative 1. Negative 1 squared is 1 plus 3, also 4. It's positive. It's positive, then the two are solution. So you can put down the answer. One is negative 1, one is 4. The two are solutions. Now, about let's summarize the formula. The formula is we have first is by definition y equal b to the power x equivalent to log base is b, y equal x. This is the first one, come from definition. The second one is product rule. Product rule is log base b x times y equals log bx plus log base by. The third one is a quotient rule. Is a log base is b, x over y equal log x, subtraction. And the fourth one is a power rule. Power rule is log b x to the power n. This n go from n log x. Now from here, and we have log b equal 1 because b to the power 1 is a b. Another one is log 1 equal what? 0. Because b to the power 0 equal 1. Another one is 7. 7 is log b to the power x is just x, because b to the power x equal b to the power x. Or you can do x go from and the log bb equal 1, and you got x. Another one, it's b log bx is also equal x, because fb is the inverse function and the b to the power x is the original function. Composite should be equal x, because logarithm function and the exponential function, they are inverse function each other. A number, you take logarithm, then take exponent. They are inverse each other, so equal x. And this one is f inverse circle f of x, also equal x. A number, you take exponent function b to the power x, and then take its inverse function, logarithm function. The exponent and the logarithm function inverse to each other. After composite, it's x. So this is x. And another one is we call change base formula. I didn't cover that formula. There's we call change base formula. We don't have that homework questions. If given a logarithm, you always can change to another base like a, x, and the log base. Change. You can. This is what we call change base formula. Change base formula. You can change from base b to base a. For example, like log 2, 3. You cannot, because on calculator doesn't have log base 2 key, so you cannot figure out this. So, but if you can change to natural logarithm e, change to base e and 3, and the natural logarithm 2, then you can use calculator and hit the key, natural logarithm key, natural ln key, divided, you will get answer. Or you also can change to common logarithm, which is base is 10. Change to base 10. Change from base 2 to base 10. Then you can use calculator, common logarithm, log key, divided, and the 2 is equal. You can use either natural logarithm or common logarithm and divided. After divided is the same answer. Then this we call change base formula from base b 2. For example, like base is 2. You can change to e, and put 3 here and put 2 here, and that's changed to natural logarithm. And this base 10, they are equal. After divided, it's the same answer, equal. So those are summarized over here. You also can see the formula, those formula on the notes. Like log 1 is 0, log base bb equal 1, because b to the power 1 is b to the power 0 equal 1. Like this, b equal x, this because the two function, a number x take exponential function is b to the power x value, and then take its inverse function is log b. After composite, because the exponential and the logarithm function are inverse to each other. After composite, just like a function, inverse function and the original function, after composite of x is x, is original x, go back to original. Or a number, you take a logarithm function, base is b, then you take its exponential function, base is b to the power, the two cancel each other, you got x, and the two cancel each other, you got x. This is just use f composite with f inverse of x equal x, and f inverse composite f of x also equal x. If you can put the other way, it's f of f inverse of x equal x, or f inverse of f of x equal x. If the two functions are inverse to each other, a number x, you take b to the power x, means exponential function. That's f of x is b to the power x, and then you take its inverse function is a log base b. The two are inverse to each other. Composite is x. Or this x, take a logarithm function and then take its inverse function b to the power x, and it's still x. Still x. Product rule, quotient rule, power rule, and this is 1 over y, go front. Change base rule. They don't have change base rule here. So those are logarithm. Then e. So you can find the notes. Find the notes. Have those formula. You can use it.